I'm very happy that Mark will give an overview of current evaluation approaches, their respective shortcomings, and then present a developed framework to determine the reliability of such approaches. Mark Cieliebak towards reliable evaluation of large language models.
Thank you very much. So there are the slides. And welcome, good morning. I would like to thank also the Data Lab for inviting me here to give this talk. I was one of the founders of the SDS conference in 2014, and it's great to be here. Can you hear me? Yeah. And it's great to be here again after 10 years, 11 years, and see how it evolved from a small workshop at our university to 600 people and such a large audience. So I will talk about evaluation of generative AI systems, which is, well, different types of generative AI. You have image generation, you have music generation, code generation, and large language models. And unfortunately for you, I work in NLP, natural language processing, so my examples will all be on text and not from images, which would be much cooler to show, like you saw in the previous keynote. But you have to deal with the text examples. So evaluation of generative AI systems. What you see nowadays a lot is, okay, thanks. Benchmarking of these foundation models. So there is a lot of benchmarks. We compare GPT-4o with Gemini 1.5 and stuff like that. I will not talk about these because I think this is a little bit like watching Formula One races. It's interesting to watch, but if you want to buy your next personal car, it's not so relevant. So I think we rather focus on what might be interesting for you. On the other hand, you can ask ChatGPT individual questions, such as, tell me a joke, or write a letter for my grandmother about my studies at the Zurich University of Applied Sciences. Very hard to evaluate what is the correct answer. So nobody knows what you are going to ask ChatGPT, and neither what would be a good answer. So these individual questions we don't look at. So what we are looking at is something which is in the middle, which is something like using LLMs or generative AI for automated processes. And there are two kinds. One is what I would call analytics. You're given a text, and then you ask the large language model, oh, tell me about this text some information. Like text classification, is the text positive, negative, or neutral? Sentiment analysis. And then the AI system outputs, well, it's positive. And this is what has been done in NLP for the last 50 to 70 years. Analyzing texts and extracting the information. Well, you have something like topic detection or named entity recognition. There is ground truth data available, people know how to do that, and people know how to evaluate it. So for sentiment analysis, you can just run your LLM on 1,000 text, take the output, compare it to some ground truth data, and then compute the F-score or the accuracy and say, oh, this is better than the previous system. This is kind of solved, so I will not look at this. If you're interested in that, look at the NLP community, computational linguists, they have done this for a couple of years. What is much harder is generative systems. So you are given a text, and you want to know, oh, give me a summary. Or you have a dialogue system, and you want to simulate children in police interviews. This is what we're doing. And the child should have some story, and the police officer asks a question, and the child should answer appropriately. And the LLM is used to generate these answers of the children. And then you have to ask, what is a good answer that brings the dialogue further, and what kind of LLM do I have to use? Do I have to use the most expensive one because it generates the best answers, but I cannot afford it if I run it with many police officers, or do I use it, well, I use GPT-3o, 3.0 because it's much cheaper, but the answers might not be as good. So we are interested in how good is the answer that was generated by the LLM, and the answer is a long text. So what is a good answer? What is a good text? You don't have to read that. I put it in very small characters, hoping that you don't try to read it. But if you just say, okay, what is a good text, and give the text to someone, then you will get very different answers. I mean, this is a long text. Maybe some people prefer short texts. You have to check whether it is correct or not, whether it is readable or not, whether the person who reads it can understand it. So there is different aspects, and you have to precisely define what aspects you are interested in. There is 4 common aspects where people say this is something like we have to always check it, which is consistency, which is basically, is the text correct or not? You have an original text and a summary, and you check whether the summary is consistent with the original text. Then it's relevancy, relevance. Is it really that what you want to have? If you say, well, tell me about this text, what is the most important information, and it gives you a correct answer, but it is not the most important information, then it's not relevant for you. And then we have fluency on the sentence level. How fluent are the sentences? How correct are they in terms of grammar? And we have coherence. How good do the sentences fit together to build a text? So these are the, I would say, standard 4 measures to say what is a good text. So assume we want to measure this. We have different means to do this. And on the one hand, we have human evaluations. So giving the task and maybe some ground truth text, some sample which is human-generated, and then the generated text of an AI, and we can ask a human, how good is the generated text? Now, human evaluations have been done since 15 years in NLP, and we have a lot of experience. And this is really, really hard to make a decent human evaluation. Why? Well, first of all, it's expensive. It's time-consuming. You need to have experts who really can assess whether the text has good consistency, good relevance, good whatever. And it's hard to reproduce it. If you take 2 humans, they will hardly agree what is a good text. So what you usually do is you take lots of humans, and they even disagree more, and then you have to figure out what is the agreement score. You have something like the annotator agreement, where you say, okay, they agree in this amount of %. And you can even measure how good humans agree with themselves. If you give them the same task 2 weeks later, you figure out that most of them don't give the same label. So there is a lot of difficulties. And usually we call these gold standards, the human labels, but I would rather call them standards without the gold. Okay, so best thing that you can do if you really have to run a human evaluation is find one single expert, give them a lot of money and a lot of time, and say, do this task. Because if you deal with many experts, you have to somehow converge them into one common opinion. Hard to do, but this is kind of what we have as comparison to figure out what is correct. So in the following, I will assume that it is the ground truth, and we look at the 3 different automatic methods to figure out how to do this automatically. And the first one is static scores. So there are some tools like the Bleu score, which takes a machine-translated sentence, and it takes a human-translated sentence, and it compares how much is the overlap of the words, and basically gives you a score. And if the score is something like close to 1, then it is good and perfect, and if it's close to 0, then it's bad. Works somehow. So for some tasks, it works decently well. For machine translation, for Rouge, you use for summarization. So you take summary generated by humans, summary generated by a machine, and then you compare it. And you can imagine if the machine writes a totally different text, but a decent summary, then there is almost no word overlap with a human translation summary. And then it gives a bad Bleu score, but still it's a good summary, maybe. And on the other hand, you can just enter one word, like a negation word, and then it flips the sentiment of some text, and then still you get a large Bleu score. So these automatic scoring systems, they don't really work for most tasks. Then we have trained metrics. What you do is you take a lot of human-generated texts and the label, how good is the text, and then you train with a machine learning system a metric which tries to mimic the behavior of the humans for assessing the text. works decently well. So if you have lots of text, then you can train these metrics, and they have a high correlation with human scores. Okay, and then we did some experiments 2 or 3 years ago, where we said, okay, we take many of these trained metrics, and now we come up with 3 strategies to make them fail. Making them fail means we generate a text where the metrics gives a very, very high score, much better than the metrics will give a score to a human-generated text, but the text is rubbish. And we have 3 strategies, which is a fixed pattern. We always give the same sentence as answer. This is the first line here. Okay, this is hard to see. Okay, so fixed pattern means just we give a fixed answer always. Second pattern is a pattern where we have a text and we can just enter some random noun in the text, so it looks always a little bit different, but it's still rubbish text. And third one is a parrot which just repeats in the dialogue system the sentence that was said before. So very, very trivial patterns, and we could show, I don't show the data here, that these strategies, basically for every metric, we find one of these strategies which is much better than any human-generated text. So these are better scored than the human-generated text. So you can make the metrics fail, which doesn't mean that they always fail, but you can make it. Okay, which gives LLMs to the rescue? So this is what many people are doing today, taking a large language model, generating some text, and then put this generated text in another language model and say, how good is the text? Very simple. So you say a prompt, which of the 2 following generated texts, text 1 and 2, is better in terms of coherence? Answer with either text 1 or text 2 without any additional output, and then you write the 2 texts. One is maybe human-generated, and one is a generated text, or you have 2 generation systems, and then it says, well, it's text 1. Sounds cool, right? Doesn't cost anything. You have your API access already for the LLM, and you can use it. There's a lot of problems with LLMs. First, if you change a text very slightly, it might change its opinion about the text. So there is an experiment where they applied different changes of text. TB is text bugger, where you just insert some white spaces in the words or some small typos, not really relevant. And TF, BA, and so on are different changes of text. And then if you take GPT-4 and run the original text versus the slightly modified text, then it changes its opinion about the text and quality in 9.4% of all cases. And if you take different tasks, so this is sentiment analysis in the top one, it's language inference and stuff like that, then it really significantly changes its opinion. So it is not consistent if you have minor changes in your texts, which don't really change the sentiment or the content of the text. So this is one thing. Second, if you run the same input prompt with the same text many times, you get different results, which means it is not reproducible, what you are doing. Oh, okay, I have to hurry a little bit. So basically what they did is they took code and generation systems, and they ran the code through some test cases, and then they compared 5 different generated codes from the same system generated for the same prompt, and they figured out that in 16% they don't fulfill the same test cases, which means same prompt, different output, semantically different output. Last one, I will make this shorter. If you compare 2 systems, like I did in the prompt before, and say, okay, compare text 1 and text 2, and you flip the ordering, then this changes significantly the output of your GPT LLM model. I don't go into the data here. So best practice, if you want to do this, do it twice with both orderings, and then only take these samples where you have the same result for both orderings, because otherwise you just have no clue what it means. So, these are the issues with the metrics that we have. There is more. Metrics that help very little or almost not at all to improve the ratings by humans. So, if you want to distinguish two systems which are close together, say you would know in theory that their performance is something like 2 or 3% apart only, then we have a statistical model developed which says how many human samples you need and how many metric samples you need to assess to figure out if they are really significantly different, the two ones. And so this is here. If you have a metric which has an accuracy of 90%, so the metric is really, really good already, and you take 2,000 or 1,000 human samples and something like 2,500 metric samples of your high-quality metric, then you can distinguish two systems which are apart by 2.2%. And if they are closer, you don't have any clue which is better. Sounds good? And the more samples you take from the metric, the better your system gets. Unfortunately, if your matrix has only an accuracy of 60%, which is still far above what current metrics have, then the metric doesn't have any influence on the scores that you get. So you need human evaluations. Second, metrics are biased. So if you take a metric and run several system outputs through the metric, then it will have a preference for certain types of systems. This is intrinsic, and we have developed a favoritism score which can measure this, which basically says this metric favors this system. And the effect is that if this is the ordering of systems here on the left-hand side, and you say, okay, this is the best system, which is on top, the human one, and BL2, 3B are the best systems, and you run it through the metric, it will have a systematic bias towards some system and put, for example, polyencoder to the top. And this Favi score that we developed, it basically shows that this favoritism is high for a particular system, and then you push it to the top. So, coming to an end, I need 1 more minute. When I compiled these slides, at the end I figured, oh, this is all negative results. Sorry, but this is how we work, so we try to break stuff, at the moment at least, in a research project, and I see a lot of hurdles that you have to, or obstacles that you have to overcome when you want to do a decent evaluation. All what I mentioned can be handled in some way. You can handle humans in annotating stuff. You can handle metrics and figure out how to do this. You can use LLMs for evaluation, but you need to do it properly, and you need to combine it properly. And this is what we are going to do next. So we are running now, or planning an InnoSwiss proposal, and we are looking for showcases, and this is where you might come into play. If you have a system where you want to evaluate how good it is in practice, something like a RAG system or a dialogue system, then maybe you can come to us afterwards or send us an email and discuss with us how to do this properly and maybe include it in the next project. Thank you very much for your attention.
Thank you very much, Mark, for this certainly consistent, coherent, relevant, and fluent talk. So, are there any questions from the audience?
I have a question as to exactly what kind of, I guess, problem you're trying to solve. If human evaluators cannot agree if one thing is better than the other, is there even such a notion of a metric? Can a metric exist that will identify this ground truth if we as humans cannot even agree on what it is?
I mean, what humans or what people in NLP usually do and have done in the past years is they took either one expert annotator and said, this is the ground truth. I don't know if he's really correct or not, but I take this as ground truth, and I don't discuss whether it is correct or not. Or you take a couple of annotators, 3 or 5, and take the majority vote and say, now this is my ground truth, because somehow you need to say what you are aiming at. But yes, you're completely right. There is no correct answer to say what is a good summary. This also depends on preferences of people and stuff like that. But somehow, if you want to evaluate at some time automatically, you need to make this one fundamental assumption saying, this is what I'm aiming at. It might be true or not. There is not the way to do it for everyone. Yeah. So, sorry, I cannot say there is a solution. There is none. Yeah.
Back there, another question.
Thank you, Mark. Maybe just a follow-up. So I imagine there's no easy solution to, let's say, evaluating a summary. But what guiding principles would you recommend if I were to, let's say, evaluate a summarization system?
So if you want to evaluate it automatically.
Or manually, or human evaluation.
So human evaluation, this has been done for a couple of years already. So what you do is you try to write down as precise as possible in an annotation guideline what you are aiming at. So you say, I want to have summaries which are short, which are very consistent, which come to the main point, and which are readable by children in the age of 5 to 7. No, they don't read, sorry. 15 to 17. And then you give some examples to the humans and say, now this is a good summary, this is a bad summary for these reasons. And then you give them summaries to annotate and check whether they agree with what you are expecting. So you give them 5 to 10 examples, and they have to learn over time that they annotate like you want them to annotate. And once they have done this, then you run the full stack annotation and make them annotate something like 100, 200 samples. And every now and then you give them maybe the same text again, the same summary, and check whether they are consistent with what they did before. You compare what the others did so that you get a good feeling of that the quality is high. If you don't do that, you will fail. So this is a little bit against crowdsourcing also, because crowdsourcing is cheap, but you get low quality usually. Okay?
One more question.
I think there is one. With a
Yes, there was one here.
Yeah.
Thanks a lot, Mark, for your great presentation. I think one of the aspects that you didn't mention is about factuality, actually. How do you have some ideas how to make sure that some generated text is factual?
Okay, so I mean, if you don't run human annotations, you mean automatically, I assume. So what you can do is you can extract the main facts of the original text in some RDF format or whatever, so in a triple, which says basically these are the facts that are mentioned, and then you do the same for the summary, and then you compare whether all the facts which are mentioned in the summary occur at least in the original text, which gives you some indication that it might be correct. I'm not saying that you really can check it. I mean, hallucinations are a huge problem at the moment, and people try to do that. There is different means to avoid that hallucinations are generated by generating many texts and comparing them. But I think for summaries, it's very easy. If you generate text, genuine text with ChatGPT, and you don't have any clue where the text comes from, it's much harder to make sure that it is correct because you don't have any source document.
Thank you very much. Please grab Mark for questions in the breaks. We have to stop here, so you have time to switch rooms. Next talk starts at 35. Thank you very much,
Thank you.
Mark.
Bye.